For the background information, the school where I work at is called Holderness School. It's an independent boarding school in Holderness, New Hampshire, and here is a view of the science building, actually that my fiance took while pruning some nearby trees. So there's our science building at Holderness School. This is actually a dormitory, and it is composed of about 275 students and about 60 faculty. The tuition is $54,100 for boarding students and $34,700 for day students, although 40% of students receive financial aid, which totals about $3.5 million in financial aid annually. The school is composed of 16% international students, 10% domestic students of color, and about 15% day students. This class that I chose for this performance assessment was the honors chemistry class. This class is composed of 8 students. 25% of these 8 students are international, 13% of these 8 students are domestic students of color, and 38% of this honors chemistry class are composed of day students. I selected the honors chemistry class because, first of all, it's my smallest class of 8 students, so I thought that would be easiest to do the performance assessment and complete it during class time. I also thought, because it was my honors chemistry class rather than my regular level chemistry, I thought they were more likely to do well on this performance assessment, and therefore I wanted to use this class for my first performance assessment. The current needs of the class, in terms of the laboratory, is I want them to develop basic lab skills and habits in order to start doing inquiry-based science labs. This all ties into my teaching goals that pertain to this lab, 4 of which. One is develop ability to apply skills already learned to new problems or situations. The second is to develop skill in using materials and tools central to chemistry. The third is develop the capacity to think for oneself, as we often work in pairs in labs. However, they did the performance assessment on their own. And the fourth is the ability to follow directions. Now, the class is currently learning VSEPR structures and molecular modeling. However, we performed a similar lab on density about a month ago, so they had already seen similar procedure and skills required about a month ago. However, the current lecture unit is on VSEPR structures, and they were working on modeling during lab, and I pulled them aside to do the density lab performance assessment. Here is how I implemented this performance assessment. My students were in the laboratory working on making molecular models with molecular model kits, working through stations. There were 8 stations using molecular model kits to work on the current unit, like I said, which was VSEPR structures. Now, I pulled the students out of these stations every once in a while, one by one, and did this performance assessment. So what was taped to the lab bench was this top part of the sheet, the objectives and the procedure. I cut this out and taped this part on the lab bench, and the first thing they did when they got to me was put lab goggles on and read this section taped to the lab bench. So they read through the objectives of the lab, and then they read through the procedure. I had this piece of paper in my hand, and I included their name on it, and I used the grading rubric, which I did not show to them. However, I did show the objectives, which all of the grading rubric incorporates all of the objectives. So I used the grading rubric to score them as they completed their performance assessment. I said they weren't really allowed to ask me questions. A few did, and I answered them, but they weren't really allowed to ask me questions. And I stood there watching them, of course, filling out the grading rubric as they completed the performance assessment. This assessment is a performance assessment because I watched them while they were doing the lab and assessed them on the skills they were doing and specifically what during the lab they were doing. So what they did was, first they read the instructions, and then they took a 10 milliliter graduated cylinder. I did not have a graduated cylinder out. They had to go to the cabinet and get the 10 milliliter graduated cylinder themselves. And then I assessed them using all materials carefully and safely. So did they use glassware safely? Did they use the unknown liquid safely? Did they not drop anything or spill anything? Number 4 was I made sure they put all caps back on bottles, so the stock container bottles of the unknown and the waste container of the non-halogenated organic waste. Number 5, I was assessing whether or not they read the bottom of the meniscus, so I was looking for whether or not they got down at eye level of the graduated cylinder and read the bottom of the meniscus appropriately. I assessed their recording their data in their notebook for mass and volume, labels, so I wanted to see if they had labeled this was the mass of the unknown, if they had labeled the mass of the unknown including the graduated cylinder, and then labeling the volume, saying this was the volume of the unknown. I wanted to make sure they have units, so grams and milliliters respectively, and I wanted to make sure that they had the proper decimal places. I assessed whether or not they recorded the mass of the graduated cylinder correctly and that they did that process correctly. So ideally they would have put the graduated cylinder on the balance, then tiered the balance, and then added the unknown liquid. This did not happen for everyone. Some people found the mass of the graduated cylinder and then added the liquid, and then found the mass again and did a simple subtraction, which was fine. And then number 8, I wanted to make sure they did not pour back into the original stock container, and that the unknown went in the unknown waste container in the non-halogenated organic waste. And then finally I wanted to make sure they washed their hands and the glassware and that their lab bench was left clean. I totaled the score and added it up for a total out of 23 total points. And I told them all before the lab this was going to count as a homework grade. Homework is only 5% of our grade, so I wanted it to count as something to make note of their effort, but I didn't want it to count too much, because this was their first performance assessment and my first performance assessment. After these students completed the performance assessment lab exercise, I did these interview questions. I held this sheet of paper and I asked them these questions. Actually, before asking them these questions, I did show them their grade from the performance assessment and show them the rubric and sort of provided a summary of my thoughts, what they did well, what they didn't do well, steps they missed, steps they added, because that helped them answer this question: were you surprised by your grade? Do you agree or disagree? I only think the interview questions are helpful, sort of really once they know everything that was done and how they did. So I did these interview questions afterwards, and I did them for everyone. So this was all 8 students in the honors chemistry class. In order to perform the data analysis, I took the grading rubric, the 9 objectives, and I averaged the score from all the students for each of the 9 objectives, and then I graphed it. And you can see from my graph the results of the data analysis. Now the y-axis, again, would be the objectives. These are all 9 objectives. And here's the percentage of the students, their average scores on those objectives. We'll start with number 1, so reading the instructions. 100% of students, when they arrived at my station for the performance assessment, read the instructions thoroughly. Now for number 2, the objective number 2, using the correct 10 milliliter graduated cylinder to measure 5 milliliters of liquid, the correct would be a 10 milliliter graduated cylinder. About 81% of students did this correctly, in that they chose a 10 milliliter graduated cylinder. The 19% of students who did not do this correctly either chose a 25 milliliter graduated cylinder, a 50 milliliter graduated cylinder, or one student who chose a beaker instead of a graduated cylinder at all to measure the volume of the liquid. Now for number 3, being careful and safe, all of the students did this 100%. No one dropped any glassware, no one took a big sniff of the unknown because they didn't know what it was. No one decided to drink the unknown or anything like that to figure out what it was. They were all careful and safe with the materials. Now for number 4, putting the caps on both the stock container and the unknown waste container, this was also 81% of students did this completely and correctly. Now, the 19% of students who did not put the caps on correctly either did not put them on the unknown waste container or did not put them on the original stock container. Now, it's important to note that 100% of the students eventually put the caps on all the containers. However, this 81% shows that only 81% of the students did that immediately after using the container. 19% of students sort of took their time putting the cap on the container, which is a problem. For number 5, measuring the meniscus appropriately in the graduated cylinder for the volume of the unknown, only 75% of students did this correctly. Now, the 25% of the students who did not do it correctly either held up the graduated cylinder in their hand to reach eye level, and because they held it up, it could tip the graduated cylinder, or that 25% of students is made up of students who did not get down to eye level, meaning they had to probably get down on a knee in order to get down to eye level for the meniscus, and that was the majority of the issues of the 25% were with that. Now, recording the data appropriately. This was about 79% of people recorded the data appropriately. So that meant including labels for the mass and the volume, that meant including units for the mass and the volume, and that meant including the proper decimal places. Most students included the proper decimal places and included the proper units. Labels were the biggest issue, in that most students did not say for their volume measurement that that was the volume measurement, or they did not say for the mass measurement that that was, in fact, the mass that they had measured. Now, number 7, mass technique. So this involved putting the graduated cylinder on the balance, tearing it or zeroing it, and then putting the liquid in and finding the mass of the unknown liquid. Now, 96% of the students did this correctly. However, many students of those 96% did not do it as I would have thought, which again was using the zero function or the tare function on the balance. Most of the students found the mass of the graduated cylinder and then put the unknown liquid in, and then found the mass of both the graduated cylinder and the liquid, and then did a subtraction. And while that is useful and that is accurate, it's not what I would think of as the fastest way or the easiest way to find the mass. Now, objective number 8, the unknown disposal. So the unknown disposal involved putting the unknown liquid in the non-halogenated organic waste container at the end, and if they had any extra during the experiment, if they got more than 5 milliliters, putting it in the unknown waste container, in the non-halogenated organic waste container during the experiment. And about 81% of students did this completely correctly. Those who did not either poured the unknown down the sink or poured back into the stock container. Now, objective number 9, washing. This is washing glassware, washing hands, and washing the lab bench. Only 63% of students did this correctly. The 37% of students who did not either did not wash their hands or did not wash their lab station. 100% of students washed the glassware. I think we've gotten that. However, a lot of the students especially did not wash the lab bench. And they're actually in the middle of the lab. One of the students did spill a little bit of the unknown, and it proceeded to remain on the table for all of the rest of the students, meaning they did not clean that up. Whether they spilled it or not, they did not clean up that small spill. When I asked the students what the most difficult part of the lab was, here's what I saw. One student said, "Sometimes under pressure, like being graded, it's hard to remember the little details." Another student said, "Figuring out where to start was the most difficult part of this lab exercise." Another student said, "Pouring the liquid without a pipette was the most difficult part, physically doing the act of pouring the liquid." The students also have access to pipettes every lab. They know where they are, and it's their choice whether or not they want to use them. When asked, "Do you think that you or your classmates would perform differently in lab if I graded your performance with a similar rubric as I had for this performance assessment?" Here are some of the responses I received. This student said, "No, in that no, we were not performed differently, because I do labs with the same carefulness, because otherwise I'll have skewed data." Another student said, "Yeah, we would perform differently, because there would be more pressure on us during the lab, causing us to not want to make mistakes, causing mistakes, and making the lab less fun." Another student said, "Yes, we'd perform differently, because we pay more attention to details, but we only get one try, so if we mess up, it hurts our grade." And that student was getting into the advantages and disadvantages of me grading their lab performance. I noticed that a lot of students during the lab were pretty nervous and anxious about the lab. Even though they had the procedure and they had done this in the past, it took a little bit of memory to figure out what to do from the past laboratory experiment on density. And so a lot of them were pretty nervous, and if they had to restart or if they messed up, they were nervous about how it affected their grade, or if they were allowed to restart, or if they're allowed to do things a little bit differently from the procedure. And this definitely caused some anxiety because these are high-achieving students who are definitely concerned about their grades. That being said, when I asked if the students were surprised by their grade, or do they agree or disagree with their grade, most students said yes, they agree with their grade and they were not surprised by it. Some of them said that they messed up in a few places and did not do very well and therefore agree with their grade as it was, and some students said that they thought they did well and therefore agreed with their grade. So I do think they thought it was a fair assessment. To close the loop in the short term, I shared this graph from the data analysis with my students, and then I talked about the data from the graph and basically what went well and what I thought didn't go as well. So things that went well were reading instructions, dealing with the materials carefully and safely, finding the mass, although I explained to them the way I would have found it using the zero function on the balance. I explained that most of them at least found the mass in some way or another. But then I talked about the things that didn't go as well, and whether that meant they didn't read the directions carefully or they didn't sort of read between the lines and think about this as a lab and what they would normally do in lab. So these are things like choosing appropriate glassware, like number 2, based on the volume that you're required to use for the experiment, putting caps on immediately, how to exactly measure the meniscus and be as perfect as you can with that, recording data and especially including labels for your data, and specifically washing everything, washing your hands especially, and making sure the lab bench is clean when you leave it. So I shared all of these things with them, and then I thanked them again for performing the assessment, especially at a time about a month after we had done a lab similar to this, and I know a lot of them from the interview were a little bit nervous about the results because they said they had forgotten some parts of the lab. So then I explained why this is important, why we need to do these things correctly and think about the steps we're going through with our lab. And while it's easy to follow steps when I give them one of the cookie cutter procedures, it's really important to understand these steps and perform these steps when they're doing their own inquiry labs, whether that's during this class or in the future. For example, using the balance correctly and the tare function, and washing their hands. I shouldn't have to tell them to wash their hands or wash the lab bench. These are just lab techniques that they should get used to starting now to continue on with science in the future. I also explained that even though certain parts of the lab did not go as well as I wanted and as well as they wanted, that this was actually a really important tool for me to realize gaps in my teaching. So apparently I'm not that great at teaching students that they need to leave their lab bench clean, and it's something that I realized that I don't stress, or putting caps back on the bottles immediately. So even though it may not have gone as well as they would have liked or as I would have liked, it's actually really important for my teaching and for them, their learning, to have this information and to move forward from this point. Lastly, I had a really interesting point where I had one student, I mentioned grad school and MSU, and I had one student say, basically, what is MSU and what is your program and what are you doing? So it provided a unique opportunity for me to talk about graduate school and what this course was about and what I'm learning and how I'm applying it to the classroom. I liked this assessment for the most part in that they were doing stations in the laboratory with molecular model kits, and I was able to pull them out individually and do the density lab performance assessment with them. And I was able, because the other students were playing, so to speak, with model kits, I was able to really focus on the density lab students because model kits involves no chemicals, so I could really focus on the students doing this performance assessment. That being said, I was unhappy, hence my unhappy face, with the assessment in that I did not think it went as planned, meaning that I expected from these honors chemistry students some better results than what I saw. I expected them to follow sort of these hidden steps that I thought they knew. For example, labeling their data with labels and units, and washing the lab bench and washing their hands and washing all the glassware, and putting caps back on the bottles and not putting the unknown back into the original container or not pouring it down the sink when it said to put it in the specific waste container. So these are all things that I thought that they had figured out by now, and clearly they had not. In the future, when I do this performance assessment with my other classes, I plan to be more transparent with my rubric, and I think this sort of goes with all assessments. It's really important to be transparent with your rubric, which means starting out with a good rubric and then showing it to the students. So I think that this part of the rubric I should show to my students. While I show them the objectives and the procedure, I think showing them the rubric so that they know exactly what they're being graded on, so that they can do well. And I think this shows trust in me, and I think this shows trust in chemistry, and I think to start off the year, especially by showing them the rubrics, and maybe continue that, maybe not, but I think that would be a great way to do this assessment, especially in the fall. I also think that my rubric needs to be much more detailed. For example, when it says mass and volume recorded with labels, units, and proper decimal places, I think I need to really break this down so that the students know what I'm looking for. So for example, I could say mass recorded, labeled as mass, unit recorded, the unit being gram, and proper decimal places being to the hundredth place because that's what our balance does. For example, putting the graduated cylinder on the balance, rule number 7 on the rubric. I think I need to show them that it's 1 point for doing that, 1 point for zeroing the balance, and then 1 point for adding the unknown liquid, adding up to 3 total points. So I think if I really break down these scores and I'm very specific about what each point is worth, then I think that they'll be more likely to make sure they do each step and do it appropriately and in the correct order. Because of this performance assessment, I realized that I need to be more specific about the lab practices that need to be followed. This involves being more strict in lab. For example, when a student leaves a cap off a bottle, I need to be strict and tell them to put it back on. I need to be strict about how to read the bottom of a meniscus and make sure they're getting down at eye level, which may means getting down onto one knee to read the meniscus. I also need to be strict about washing hands at the end of lab, whether it's an unknown that turns out to be water, like it was for this performance assessment, or for something like strong sulfuric acid. I need to make sure they're washing their hands at the end of lab, and I can do things like putting posters up around the room by the sinks or by the door before they leave that tells them and reminds them to wash their hands. Overall, this was a very valuable assessment, as I think most of the less successful assessments can be. I actually learned a great deal from it that will affect my future teaching.